Hey everyone, in this video we'll be talking about limits to infinity. So limits to infinity is a pretty common concept that you'll see in pre-calculus and calculus and sometimes algebra 2, but it is really important that you know how to solve these. So there are three concepts in limit to infinity. You have something called Bobo, Botten, and etc. Now we'll get into this in a second, but before I progress on what these exactly mean, I'm going to show you an example of what a limit to infinity means. This just refers to a limit that instead of the traditional number here, that x goes to a traditional number, you're going to have infinity, or this could be negative infinity. And then you're going to have your function. So it's basically just calculating what f of x, the limit of f of x, when x approaches infinity. So that could be infinity or negative infinity. You'll have to do that based on the function you're given. So now what exactly does this Bobo, Botten, and etc. mean? Now, unlike a typical limit question, where we'll easily be able to plug it in or just factor it down or maybe take the derivative, in limits to infinity, you sometimes have to incorporate these rules that will help you simplify it a bit. So Bobo just means bigger on bottom 0. Botten means bigger on top none, and etc. means exponents are the same, divide coefficients. Now what that exactly means is that when you're given a function that goes to infinity, or let's say negative infinity here, let's say when you have 5x squared plus 1 over 6x cubed minus 7, you look at your exponents, or your biggest exponents, right? So in this case, on the top, your biggest exponent is 2. Right, so our biggest exponent is 2, and on the bottom, our biggest exponent is 3. Thus, out of these three, the one that refers to the bigger exponent on the bottom is Bobo. Now, Bobo is bigger on bottom, which refers to these exponents, 0. 0 just means that we can attribute this to 0. Pretty simple. Let's look at another one. Let's say limit x goes to positive infinity. And now let's make our function. This is, instead of f of x here, we're going to write, let's say, 7x squared plus 3 over 2x. On the top here, our biggest degree is 2, and on the bottom, our biggest degree is 1. So this refers to BOTN, Botten, which is bigger on top, none. So this we can say is none. But when you get to calculus and sometimes pre-calculus, this won't just be referred to as none, it'll be referred to as a slant asymptote. And I'll explain how to find the slant asymptote in a later video. But that's all you have to know for that. Now, etc. This is the weirdest one. So, we have our limit goes to infinity. Let's say 12x cubed plus 6x squared plus 3 over, let's say, 4x cubed plus 2. Now, we have all this jumble going on here at the top, and we don't have any exponents at the bottom, but we do have our biggest one, which is 3 and 3. Now, if they match up, let's go to etc. Exponents are the same. In this case, they're both 3. Divide coefficients. Dividing coefficients is the coefficient of what's attached, the number in front, to our biggest exponent. So in this case, 12 on the bottom, it's 4. So you divide them, is equal to 12 by 4 is equal to 3. So that's just the basics for limits to infinity. So I'll go over more practice problems and more difficult questions in a later video. Thank you for watching.